The wastewater treatment process is a microbiological process. Most people are not aware that it is microorganisms that do most of the work of cleaning the wastewater. The microorganisms are the VIPs of the treatment process. Wastewater leaving our homes, industries, as well as stormwater runoff enters the treatment system through sewers, where it flows through screens trapping large debris. Then the flow rate is slowed down to about 2 feet per second to allow grit, sand, and small stones to settle out. The wastewater then enters primary treatment, where most of the larger floatable solids and greases are removed. The remaining water contains mostly dissolved organic substances. This water flows into the aeration basin, which is the microbiological hub of the treatment system. If you were a microorganism, this would be the best job for you. All you would have to do is swim around in the aeration basin and eat food until it's gone. Then you move to the clarifier, where you stick together and go to sleep. Then when you are hungry again, you are pumped back to the aeration basin, where you can eat all over again. They just eat and go to sleep and eat and go to sleep. Those of you who are parents know exactly what I mean. Wastewater treatment systems are designed to house microorganisms and bring them in contact with the organic material in sewage. Microorganisms convert organic pollutants into beneficial materials. The aeration basin is a microbiological zoo. It is made up of about 95% bacteria, 4% protozoa, and about 1% metazoans. So let's take a look at some of the microorganisms in our microbiological zoo. These are bacteria. They are the ones that are responsible for removing most of the organic material in the wastewater. As the bacteria feed, they begin to multiply exponentially. This provides plenty of food for the protozoa. Because they don't eat the organic material, they like to eat the bacteria. It is their chocolate. This protozoa is a free-swimming ciliate, and if you watch closely, you can see it drawing bacteria into its mouth. It does a great job of helping to clean the water of bacteria. These are crawling ciliates. I call them the Dow bathroom cleaning scrubbing bubbles. Once the bacteria eat most of the organic material, they begin to clump together to form a biological solid called floc. As the floc particles begin to form, these crawling ciliates begin to multiply in the system. They cannot swim, and they need the solid particles to walk on and feed. They feed on the straggling bacteria on the edges of the floc particle. Now the aeration basin becomes the survival of the fittest. Other protozoa that have the ability to better compete for the remaining bacteria begin to dominate in the system. This is a stalk ciliate. It simply stands in one place, creates a vortex with its cilia, and sucks the bacteria into its head. It doesn't have to go anywhere, it brings the food to it. This one reminds me of my son Daniel, who sits on the sofa and sucks food from the refrigerator straight into his head. As the time the microorganisms remain in the aeration basin increases, stalk ciliates that have multiple heads begin to dominate. This one is called the colonial stalk ciliates. In order to survive, they need multiple heads because very little bacteria are left in the system for feeding. This one reminds me of my oldest son, Lawrence. When Lawrence is home, Daniel does not eat. When they both are home, I do not eat. We often say the greater the number of heads, the longer the solids have been in the tank. Once most of the organic material or the food is gone, they begin to feed on one another. This is a suctorian. This one is mean. An innocent protozoan will be crawling along, minding its business, when all of a sudden it is sucked into the suctorian's tentacles. If it was nice, it would kill the poor little protozoa, but it is not merciful. It simply shoots poison into it to paralyze it, then slowly sucks the life out of it. This may not be true for you, but this one reminds me of my ex-mother-in-law. If the microorganisms remain in the tank even longer, metazoans will begin to dominate in the system. Metazoans are higher life forms that are both male and female. This one is a nematode. It does very little to remove organic material from the wastewater. It just eats other protozoa. And since they take a longer time to multiply, the presence of lots of nematodes tells us that the microorganisms have been in the aeration basin for a long time. Similarly, this is a water bear. It is also an indicator of how long the microorganisms have been in the aeration basin. It does very little to clean the water, but it feeds on other protozoa and smaller metazoans. This one really looks like a little bear, except it has 8 legs with claws. It will grab its prey, poke a hole in it, and then suck all the juices out of it. They are male and female. The male will bite the female and shoot his sperm in her and fertilize her, but the female will molt out of her skin and leave her fertilized eggs inside her fully shaped skin. The eggs will hatch, and the little baby bears will break out and go out into the world to suck life out of other microorganisms. The wastewater treatment process produces 2 final products: the treated water, which is discharged into the waterways, and the biological solids that are formed after the organic material has been removed. The treated water is called final effluent. Final effluent discharged to the waterways is tested to make sure it meets the requirements for indicator bacteria. Fecal coliforms is an indicator bacteria, and they are used as indicators of pollution. Indicator bacteria do not cause disease. Their presence indicates impacts from human, animal, and other sources. Environmental sources such as geese, stormwater runoff, and even our pets can also carry microbes that cause illness. The treated final effluent meets the discharge water quality requirements. Our second final product is the solid stream called biosolids. Biosolids are a nutrient-rich final product of the sewage treatment process that can be used as a fertilizer. But they may contain some harmful pathogens, so before it is given for use as a fertilizer, it must be tested also. Biosolids are tested for fecal coliforms or salmonella. They're tested for viruses, and they're tested for helminth ova, which is a parasite. This is a helminth. To the right is the ova or egg. To the left is the roundworm it would turn into if it got inside of the stomach of its host. The biosolids is also tested for virus. The district produces Class A exceptional quality biosolids. Our biosolids are used in farms, golf courses, and parks. They were used to transform the roof of an underground parking garage into the Maggie Daley Park in downtown Chicago. They were also used in landscaping on Chicago's acclaimed 606 trail. Thank you. For more information, you can go to www.mwrd.org.